Welcome to 2.2. We're going to look at notes on modeling distributions of data. So first, let's talk about normal distribution and normal curve. Those are described by sometimes what's called a normal density curve, which is, again, just kind of like that bell-shaped curve we've been talking about for a couple days. Any particular normal distribution is completely specified by two numbers. So the first one is mu, being the mean mu, which is the population mean, and the standard deviation sigma, which is the population standard deviation. So it's abbreviated as normal distribution, and it uses kind of like an ordered pair. A capital N goes first, and then whatever the mean is, and then a comma, then the standard deviation. So whenever you see that symbols, that means that they're talking about a normal distribution with this mean and this standard deviation. So let's talk about the 68, 95, 99.7 rule. Sometimes some textbooks call it the empirical rule. This only works for normal distributions. So one standard deviation to the left or right of the mean, left and right of the mean, is 68% of the observations within one standard deviation of the mean. All right, the second thing is approximately 95% of all observations fall within two standard deviations of the mean, and approximately 99.7% of the observations fall within three standard deviations of the mean. And technically it's like plus or minus, so it's positive and negative on both sides. So what we're talking about is if you picture a normal curve, this would be the mean. On a normal curve, a mean has 0. If we're talking about the number of standard deviations things fall. This would be 1. Pretend that's a straight line. This would be -1. So what they've found is they found that if we have a normal distribution, within one standard deviation on either side of the mean, together this makes 68% of the area of the curve, or otherwise known as 68% of the observations. If we make another curve, and again this being the mean, and then we have a standard deviation or z-score of 1, and then 2, -1, and -2, so now we're falling within plus or minus, or we're falling on two standard deviations on either side of the mean. So this entire area is 95%. So 95% of the area under the curve, which also corresponds with 95% of the observations. And then finally, squish this in here, 0. And if we go 1, 2, 3 standard deviations, so -1, -2, -3 standard deviations, the area of the curve in between +3 and -3 standard deviations is 99.7% of the area under the curve, which also corresponds with the percentage of observations between those two values. So hence the reason why it's called the 68, 95, 99.7 rule. So let's talk about the standard normal distribution. The standard normal distribution is basically a big fancy name for a curve that has a mean of 0 and a standard deviation of 1. So basically each of these x's has been standardized and turned into a z-score using the z-score formula. So for instance, this guy here, the mean of a standard curve is 0 because if the x at this value and the x bar at this value are the same value, when you subtract them, x minus the same mean, right, if they're the same values, that would make 0 on top. And 0, of course, divided by anything is 0. So that's why 0 is 0 units from the mean. 1 is 1 standard deviation from the mean. 2 is 2 standard deviations for the mean, otherwise known as a z-score of 1, a z-score of +2, a z-score of -1, a z-score of -2. So remember that z-scores represent the number of standard deviations a score is from the mean. All right, so let's look at an example. The distribution of weights of a 9-ounce bag of a particular brand of potato chips is approximately normal with a mean of 9.12. I always like to write the stuff down that they give me from the problem. And a standard deviation of 0.05 ounces. Probably should have put ounces over here. Draw an accurate sketch of the distribution of potato potato chip weight. Be sure to label the mean as well as the points 1, 2, and 3 standard deviations away from the mean. So that's pretty much standard. Let's draw our curve. You just basically make a bell curve. In the middle is going to be your mean, 9.12. All right, so then if we go 1 standard deviation, and usually it's about where the curve starts to flare out a little bit. So since we're positive 1 standard deviation from the mean, we're going to add, basically at this point it's going to be 9.12 plus 0.05. See that we added 1 standard deviation? So this will be 9.17. And then if we go out one more, this will be 9.17 plus another standard deviation, which will be 9.22. And if we go one more standard deviation from the mean, this will be 9.22 and add 0.05 and we'll get 9.27. So all we do is just keep adding a standard deviation as we go. Now if we're looking at the left side of the curve, we're going to subtract a standard deviation. So this is going to be 9.12 minus 0.05, which is 9.07. Right? And then we go 2 standard deviations to the left, which would be 9.07 minus 0.05, which is 9.02. And then we go one more, so this will be 9.02 minus 0.05, which is equal to 8.97. And that's what they're talking about. We labeled the mean. It's in the middle, so we're good. And then we did the points 1, 2, and 3 standard deviations away from the mean on the positive side and on the negative side, so we are winners. All right, number 2 says refer to exercise 1. So I put the example of an exercise 1 up here. The textbook always puts the numbers at top. Rules, use the 68, 95, 99.7 rule to answer the following questions. Show your work. All right. What percent of bags weigh less than 9.02? So really think of this as shading. So here's, well, maybe we don't shade all of that. Maybe we just shade the part underneath the curve. There we go. So what we want to really know is what the percentage is of this little tiny piece of area under the curve. Remember that a whole curve is 1. So now let's use the area under the curve. So here is the mean. Here's 1 standard deviation. Here's 2 standard deviations. So basically we're 2 standard deviations from the mean. So I'm going to go 2 standard deviations on the other side because I know that this whole piece right here in blue is 95%. So if I did 1 minus 0.95, that would basically be what's left over on either side. So that would be these 2 areas in black. Well, I don't want both areas in black. I only want 1. So I'm going to divide by 2, and my answer is 0.025, and it says percent, so I'm going to turn it into a percent, 2.5%. Right? Between what weights did the middle 68% of the bags fall? So the middle 68% is 1 standard deviation from the mean. So there's the mean. There's 1 standard deviation. There's 2 standard deviations. So between what weights? So that would be 9.07, 9.07, and 9.17. All right, part C says, what percent of 9-ounce bags of this potato chips weigh between 8.97 and 9.17? So again, we need to find where those numbers are. 8.97 is here, and 9.17 is here. So we want to know what the area is under the curve from these 2 points. All right, so if we notice from here to here is 1 standard deviation. So we know that we have at least 68% of the curve taken up. Then from here to here is, we are, let's count, 1, 2, 3 standard deviations from the mean on either side. 3 standard deviations of the mean is 99.7. So these 2 areas here are 90 from here to here. Underneath the curve is 99.7. So what we've left out here is this other little piece, right? We need to really know what this is. Well, if I was to take the 99.7 from here to here and subtract the 0.68, then what would be left is this area here. Let me color it in red. What would be left is this little chunk and this little chunk, right? So hopefully you can kind of see where we're going with this. So I'm going to have 68 plus, I'm going to take the 99.7 and subtract away the 68 to get the two pieces that are left in red, sorry. And I only want one of them. I only want this one. So I'm going to divide that area by 2. Stick that in your calculator and we should get 83.85%. Okay? So we will go over this again tomorrow, but I really wanted to make sure that you understand or at least have a chance to review this video so that you can see it at a little bit slower pace. All right, and then don't worry about what number or what D says on your paper, so just cross that out. Let's look at number 3. Estimate the mean and the standard deviation of the normal density curve in the figure below. So what we want to do is estimate where the mean is. So because this is a normal curve, we know that the mean is at the peak. So if we draw a line straight down, let's see if I can do it. Oh man, pressure's on. It looks like it's approximately 10. So the mean is approximately 10. Now the standard deviation is usually about where the curve starts to change. So you kind of get better at this as the more often you do it. Yeah, I'll try and draw a straight line there. But the more that we do it, you'll start to see where that is. So mu is approximately, it's almost 12, so we'll call it not mu, sigma is approximately 2. Okay? And I know you're kind of like, what? But I promise that's where it is. So you're just kind of like dividing this piece from here. If you think of it from here to like where the 17 is, you're kind of trying to divide that into equal pieces. More like where the 16 is. So kind of trying to divide that space between 10 and 16 into equal pieces. So maybe that's an easier way to think of it. All right, so now let's practice using the tables. These tables are in the back of your book. They also are going to be on a handout that we're going to be able to use on the test and also on our homework. So you want to be familiar with these. So what this table A does is it allows us to find z-scores or the value of z-scores without using our calculator. This is the old school way. So what you do is you look at the z-score column. There's 2 table A's. One has negative values and one has positive values. So I just copy pasted the negative values. So you can see the first 2 numbers there are negative 2.4. So you go down this line where the z-scores are until you get to negative 2.4. And then you look at this last number 6. So then we go over until we see 6. And that's where basically the area of the curve. So if I drew a picture of this, this is a z-score, so we know that the mean is 0. This is negative, so we know we're talking about to the left. So there's 1, 2, right? There's 3, so we're at 2.4. So what we're doing is we're talking about the area that's less than this under the curve. So that is 0.0069. Little tiny piece, right? About 6% of the curve. Let's try another one. So let's do z is greater than. So again, you really want to get into the habit of drawing this picture because that's part of the work that's required on the AP test. So again, this is a z-score, so the mean is automatically 0. The standard deviation is automatically 1. So this kind of looks the same as what we were just doing, except for this one says positive 2.46. So positive 2.46 would be about here. Greater than, you shade to the right. So hopefully you can see it's a pretty similar amount of area. This is the positive z-scores, so this is a different page, the next page in your tables in the back of the book. So now if we go down the z-scores, go down until we find 2.4, little bit further down this time. And then we go over across until we find 0.06. And you might find that, wow, that doesn't look like that's 99.31% of the curve that's shaded. Well, the problem is that the tables can actually only read from the left all the way to the right. So the table is actually showing you the part that's shaded in red. So because we want the part that's shaded in blue, and we know that the area under the curve is actually a total area under the curve is 1, we're going to do 1 minus 0.9931, which conveniently enough is the same as what we got last time. All right, so the area under the curve, when you use a table, can only go from the farthest left value all the way to the right. So whenever you have a greater than symbol and you use the area under the curve, you got to do 1 minus whatever the table says. All right, let's look at part C. Let me get rid of these markings. Maybe. There we go. Part C is, this is a AND statement. So we've got both of these at the same time. So 0, because this is a z-score, we know that the mean is 0. All right, so here's almost -1 standard deviation. Here's +1 standard deviation, +2, +3. So what we want is from 0.89, which is probably about right here, and to 2.46. So we want this area. So whenever you have a piece like this and you're using a table, you basically are going to take the big area minus the little area. Right? You don't want to have a negative area. It's probably pretty obvious. So the big area is 2.46. So I'm going to go down, going to go over. Oh wow, look, the same value we got last time. So this is, the big area is 0.9931. I don't want to subtract from 1 this time because I want basically this whole area. Okay, and that's what that just gave me. Now I want to find the little area, 0.89. So I'll do that one in green. So I go down 0.8, then I go all the way over until I get to a 9, 0.833. So what that means is that the area from the end to right here, to right there, is 0.833, 0.8133. So I'm going to subtract, and what's left over will be the red shaded area in the middle, which I got 0.1798. All right, let's try another one. So now we have the same thing, except for, that's ugly, except for this is on the negative side of the curve. Much prettier. All right, so let's look at 0. We know that the mean is 0 because this is a z-score. There's -1, -2, -3. So we're at -2.95, which would be about here, and -1.27, which would be about here. So we're talking about the area in between these two boundaries, right? We have a compound inequality. So that means between those two areas, kind of the same thing it meant when we did number lines and all kinds of fun stuff in algebra. So we always want to take the big area minus the little area. So in this case, the bigger area is going to be from -1.27. So you go all the way down to -1.2, and then we go all the way over to 0.7, which is 0.1020. It makes sense for it to be such a small area, because if you think about it, 0 from to the left is actually 50%, and 0 to the right is 50%. So because we're to the left of the curve, we would really expect that to be a pretty small number. If it wasn't small, we would be a little bit suspect. Now we're going to take away -2.9, which is up here, and we want to go all the way over to where the 5 is, 0.0016. So we're going to take away 0.0016, and we're going to get 0.1004. So the area of the light blue shaded area is about 10% of the curve. All right. Now, let's use your notes. So what I did here was I just basically typed what the directions were so that you would have this to follow and maybe try it on your own and see if you can do it. My PowerPoint wasn't writing mu right, so I just spelled out the word mu. I know that it's supposed to be a Greek symbol, and I just wrote out the word sigma, so I didn't have to sit here and keep playing with the math autocorrect. So anyways, in your TI Spire, you're going to make sure that you go to the house and create a new document and not save the old one. And then go menu. When you see menu, you'll see a drop down that goes to probability, then distribution. And then there's a function called normal CDF. I think it's the second one on that screen. And then you're going to have a lower bound value, and we're going to put in negative 2.05. This is 5a, by the way. And then you're going to put the upper bound of 0.78. Make sure that mu is set equal to 0 because these are z-scores. Sigma is 1 because these are z-scores. Tab to OK, and your calculator should spit out and round to 0.7621. You do the rounding. Your calculator won't round for you. If you have a TI-84, you're going to do something pretty similar. There's a couple different buttons you're going to use. You're going to hit your second VARS key, and above the VARS key it should say DIST in the little, off color keys or whatever. You also are going to have a command called norm CDF. Yours won't say normal CDF. It'll say norm CDF, and you'll enter the lower bound if it gives you prompts. The upper bound, the mean is 0, the standard deviation is 1 because these are z-scores. You have to tab or arrow down to calculate, and you'll also will get the same value. If you have an older TI-84 or a TI-83, then you will follow the same instructions, but you will not have the prompts like the lower bound, upper bound, so you'll have to use parentheses, and you'll have to know that the lower bound is negative 2.05, 0.78, and then 0 and 1. And then hit enter, and it'll give you the area. So, of course, we will go over this again tomorrow. But I really wanted to make sure that you tried this on your own to see if you can do it and go from there. All right, let's continue. All right, so now let's work backwards. Let's go from the area to the curve. So basically, to the z-score. So if I have area under the curve, and if this is 0, this is really talking about 63% of the curve. Right? And it's talking from 0 to 63. So if I get to 0, that's 50%. So I want a little bit more to get to 63%. So what I really want to know is what z-score is holding that boundary at 63%. So the way that you do this is you search inside here and you keep looking for what is the closest to 63%. And you can see that it falls in between those two values. So it's going to be here's your first number, 0.3, and then you actually are going to pick the number that's closest to it. So 0.63, this is 0.07, and this is 3.1 from it, so 0.33 is the closest value. So pretty cool. Now, all right, so let's look at this one. I have a little helper now because she was whining. 75% of all the observations greater than z. So we'll draw a curve. This will be 0. And we're talking about 75% of the observations greater than z. So start from here and go back 75% of the curve. So we're right here, about right here. So we want to know what z-score this is. So remember that table A can actually only go from the left to the right, which would be 25%. So you search in the middle here, look through all these crazy numbers to try and find the two numbers that are closest to 25. Oops, these two numbers are closest to 25. So which one is closer? So this one is 14 away from it. This one is 17 away from it. So this guy here is closer. So you go all the way over to the left to see what his beginning numbers are, negative 0.6. You go all the way to the top to see what his second number is, 7. And that's his z-score. Winner. All right.